We discuss RC circuit in this lecture. A circuit containing a series combination of a resistor and a capacitor is called a RC circuit, as shown in this picture. A direct current circuit may contain capacitors and resistors. The current will change with time. When the current is completed, the capacitor starts to charge. The capacitor continues to charge until it reaches its maximal charge. Once the capacitor is fully charged, the current in the circuit will be zero. This is the charging process. For t smaller than 0 second, the switch is open and the charge on the capacitor is 0. At time t equals 0, we close the switch. There is going to be current going through the circuit. Positive charge will accumulated on the plate of the capacitor that are connecting to the positive end of the battery. Negative charge will accumulate on the other plate. The magnitude of current will go down. If we use Kirchhoff's loop rule, we will have an equation. The potential over the capacitor is given by Q over C. The potential of the R is given by I times R. Now these three circuit elements, EMF, capacitor, and R form a commutator loop. So we have the potential of those three elements has to add up to 0. So we have epsilon minus Q over C minus IR equals 0. At the very beginning, there is no charge on the capacitor, so there is no potential for the capacitor. At the very beginning, the initial current should be given by epsilon over R when t is 0 second. At very long time after we close the switch, there would be no current in the circuit because the capacitor is fully charged. The potential of the capacitor equals the potential of the EMF. So the charge on the capacitor is given by C times epsilon 0. We want to find out the time dependence of the charge on the capacitor and the current. Now, after some calculation, which requires some knowledge of calculus, so we present the conclusion here. The charge as a function of time is given by this equation. At t equals 0, e to the power of 0 gives us 1. So the charge at t equals 0 is 0. The interesting point is when t equals r times c, this expression e minus t over rc reduced to e to the minus 1 at t equals r times c. And e to the minus 1 is 0.368. 1 minus 0.368 gave us 0.632. So at time t equals r times c, the capacitor is charged to its fully possible charge by 63.2%. We can also use this equation to find out the charge on the capacitor at any given time. We just need to replace t by the time. And R times C is a special time for this RC circuit. We call it time constant tau of this RC circuit. It gives us how charge is changing over time. For the discharging process, we have a capacitor and a resistor connected. No battery this time. At t equals 0, the capacitor is fully charged with charge Q. At time t equals 0, we close the switch. There is going to be current going through the circuit. So the charge and the capacitor decreasing. Now at t equals 0, the potential of the capacitor is at its maximum. So we'll have maximum current at t equals 0, and the current will go smaller and smaller over time as charge and the potential of the capacitor goes smaller and smaller over time. For the discharging process, the charge as a function of t is given by this equation now, QE to the power of minus t over RC. We still have this time constant tau, which equals R times C. R is the resistance of the resistor. C is capacitance of the capacitor. When time t equals tau, which is R times C, we have about 36.8% of charge left on the capacitor.